Easy Chemistry by Venla. Today our topic is free radical from reactive intermediates. This is third one. I already explained the carbocation, carbanion. Please check it once. Free radicals are trivalent carbon intermediate have 7 valence electron. Hybridization is sp2, geometry is trigonal planar. So what is the bond angle? 120. This is unstable, highly reactive, paramagnetic. Free radicals are neutral charged. This is about the structure of free radical. Next, second one is generation. In generation, first one is thermolysis. In presence of thermal, it forms free radical. This is called anti-knocking agent. Azomethane. In presence of thermal, it forms free radical like this plus N2. This is azomethane. Same like this, benzoyl peroxide. This is benzoyl peroxide. Bond break like this. In presence of thermal, it forms free radical. This is free radical. Next, second one is photolysis. Same in this azomethane, bond break like this, but here in presence of photolysis means sunlight plus N2. Same benzoyl peroxide also bond break like this in presence of sunlight. It forms free radical like this. This forms like this free radical. Next, nitrate also same like this. Next, third one is redox reaction. Benzoyl peroxide in presence of copper, it forms, this is free radical, and Cu plus 2. Here this is gain of electron. Gain of electron means this is reduction. Here loss of electrons take place. That means oxidation. Fourth one is Fentos reagent. Here Fentos reagent Fe plus 2 in the presence of hydrogen peroxide. This is hydroxylating reagent. Here Fe plus 2 reaction with hydrogen peroxide bond break like this. It forms free radical and anion. This free radical reaction with benzene and finally hydrogen radical formed. Hydrogen radical reaction with Fe plus 3, it forms Fe plus 2 and cation. This cation reaction with OH minus, finally it forms water. This is the Fenton's reagent. Next, fifth one is auto-oxidation or self-oxidation. This cardinal reaction with Fe plus 3, it forms breakdown of hydrogen, it forms free radical like this, and H plus it and Fe plus 2, this forms Fe plus 3 and hydrogen radical. It reaction with O2, this is here one free radical, here one free radical. It forms like this. This is free radical. Again it reaction with H plus, it forms this one. Again it reaction with, here breakdown of hydrogen. Finally it forms carboxylic acids. Next, sixth one is anodic oxidation. Anodic oxidation is, here positive charge is there. In this positive charge, how to remember anox? It is positive charge. Here one free radical, it forms CO2 plus radical. Finally it forms alkane. This is alkane. This reaction is known as Kolb's electrolysis. Kolb's electrolysis, it forms alkane finally. Next, cathodic reduction. Cathodic reduction, it is negative charge. Here, how to remember cathodic reduction is, simply it is red cat. You can remember red cat. Reduction cathodic. This cathodic and anodic mainly important in electrochemistry, which is physical chemistry. Very important for NEET, CSIR NET, GATE, all competitive exams. Example, these two radicals combine together and forms like this. It forms bond. Next, reaction with 2H plus. Finally, it forms pinacol. This is the pinacol. Pinacol is prepared by electrolysis. Next, reaction with alkali. Here OH, reaction with NaOH. It forms like this. Here one oxygen radical, that reaction with FeCN6 3 minus radical plus Fe2. Here Fe3 then becomes to Fe2. Here CN6 3 minus can convert it into -4. This is the final product. Next, stability. Third one is stability. Electron deficient species stabilized by ERG and conjugate EWG. Next, detection. Increase the rate of reaction by radical initiator. What are the radical initiators? Hydrogen peroxide, peracid, AIBN. These are increases the rate of reaction. At the same time, addition of radical inhibitor that will decreases the rate of reaction. These are radical inhibitor, carbonyl and quinone. Appearance and disappearance of color during the reaction. This is the ESR spectra. Disappearance of lead mirror during the reaction. By these, you can detect these are free radical. Chemical reactions. Chemical reactions are two types. First one is free radical substitution reaction. Next, free radical addition reaction. So first one is substitution reaction, free radical substitution reaction. What is the reactivity order? Reactivity order is first benzyl, allyl, tertiary, secondary and primary. This is the reactivity order for free radical substitution reaction. Example, in presence of H nu Br2, it forms CH3, CH3, bromine, CH2Br. Here CH3. This is primary, this is tertiary, this is secondary. Order is tertiary is greater than secondary and primary. So in this tertiary hydrogen, removal of tertiary hydrogen by adding bromine. Another example, same reagent, the product is like this, bromine plus HBr. This is N-bromosuccinamide CCl4. The product is like this, here addition of bromine. Next, CH3, same reagent. How it forms? CH2Br. These reactions are called Ohl-Ziegler reaction. Here CH3, CH2Br. In presence of TBTH and AIBN, it forms CH3, that is alkanes. Here gain of hydrogen. Gain of hydrogen means reduction. But here loss of hydrogen is take place. Loss of hydrogen means it is oxidation. This is 6-halo alkane. 6-halo alkene. 6-halo alkene. 1, 2, 3, 4, 5, 6. In presence of same reagent, it forms like this. Next, finally, free radical addition reaction. CH3CH double bond CH2. This is olefin. In presence of H nu HBr. How it forms? CH3 CH2 CHBr. This is anti-Markovnikov rule. Anti-Markovnikov rule is only applicable for HBr. This negative part of the reagent is added to wherever the more hydrogen, then we'll add bromine. Olefin have more number of hydrogen. These olefins involved in free radical addition reaction. It mainly follows anti-Markovnik rule. This anti-Markovnikov rule or Markovnikov rule I already explained in the hydrocarbons from alkenes. If anyone want, please check out these previous videos. So this is the end of the free radicals. So that's all for today's videos. I hope this explanation made the topic simple and easy to remember. If you found this video helpful, please like, share, comment and subscribe to Easy Chemistry by Vanilla. If you have any doubts or suggestions, let me know in the comments. Thanks for watching. Keep learning, keep practicing, and see you in the next video.